Hey there. Well, since we have nothing to do but watch YouTube videos while the dark cloud passes over, I decided I'd throw my hat in the ring and spend a couple hours of time and make a video that will kill some time for you, however much that is. And I'm going to talk about something that's hopefully pretty interesting, and that would be the geology of the Sphinx. And by the end of this video, you're going to know why that head on the Sphinx does not show anywhere near the erosion that the rest of the Sphinx does. And I'm also going to try to give a few guesses at the age of the Sphinx, and I might present a few other people's theories on dating of the Sphinx. And I'm going to go back a little ways in time here. We'll take a closer look at the actual geologic map of Egypt. So almost all of the rock around the Giza Plateau and all along the Nile goes all the way back to about the Paleocene. That's about 65 million years ago. As you go south on the Nile, you'll see the older Eocene, Paleocene, Oligocene. Most of this stone is sandstone or limestone. Most of it around, well, at the northern part of the Nile is limestone. And you'll see why it's limestone. There's 3 different types of limestone that the Sphinx is made out of. So 21,000 years ago, you can see that northern Africa right here the water is actually receding from the continent of Africa. $50 million years ago in the Paleogene, you can see that a lot of North Africa and Saudi Arabia is underwater. Now everywhere that you see it blue there on inside the African boundary there is where you'll find the heaviest limestone deposits. But if you go even farther back, 94 million years ago, you can see that the whole area around the Nile is underwater, and there's massive deposits of limestone and sandstone and some other related sedimentary type rocks. And you can also kind of tell just from this that why the Nile is where it is. It would be in the basin of that water deposit right here. The location of the Giza Plateau is this entire area here, and the Sphinx is right here, and then we see the 3 pyramids. Going in a little closer. And by the way, this entire area up here where the pyramids are, the Great Pyramid being on the highest ground, Pyramid of Capri is a little lower, but still everything is higher than the Sphinx. The Sphinx is pretty low over here. And zooming out a little bit, the Sphinx is right here in the middle, and all of this area here is limestone. Different types of limestone. This, of course, is just deposits from the Nile, in the green area here, probably over here too. And from farther out, this is what it looks like. But this whole area, right, all through here, was underwater, and then it came all the way down, of course, earlier on. So this entire area, that's why there's so much limestone and sandstone around here, but nothing else. You don't really see a lot of volcanic rock, or either extrusive or intrusive, and there's no granite here. You'll have to go, I think, to the Aswan Quarry, which I believe is probably south, but I'm not sure exactly where on here. I'd have to look it up. But this is the and then this area here is along the Nile going south on both sides is the 50 million year old limestone and sandstone. So using the contemporary dating system here, and this is just for reference for trying to visualize when things could have been built. The old kingdom right here at 2613 to 2180. Now the exact years of the golden years are a little bit different, but it was right around in that area. And a lot of people think that that's when the Sphinx was built, okay, just for the record. But there's so much disagreement that I don't even know really what everybody is saying. So don't worry, the good pics are coming up here, but just to get it, in black and white here, I'll just go ahead and read what we have. The Sphinx is carved from the natural limestone of the Giza Plateau, known as the Mokattam Formation, and that's the different layers of limestone here. Members 1, 2, and 3. An Eocene period sea retreated 50 million years ago, or at least it started to retreat. It was actually there, remember, 95 million years ago, but they're saying that it retreated 50 million years ago. But it really wasn't retreated, it was in the process of retreating, leaving an embankment that became the northwest part of the Giza Plateau. And that was basically a pocket of water that remained after the sea had retreated. The Sphinx is cut from the lowest layers of the Mokattam Formation, those layers lying directly on the harder petrified reef, which would be the bottommost and the oldest and the hardest rock. We label the Sphinx geological layers member 1, 2, and 3, after the work of geologist K. Lal Gwari. As the sea receded, a shallow lagoon formed above a shoal and a coral reef in what is now the south-southeast part of the plateau. Over millions of years, carbonate mud petrified to become the layers from which the pyramid builders quarried limestone blocks and from which they carved the Sphinx. The lowest stratum of the statue is the hard, brittle rock of the ancient reef, member 1. This layer rises to a height of 12 feet at the Sphinx's rump and only 2 to 3 feet at the paws. Most of the Sphinx body is cut into member 2. 7 layers that alternate softer and harder as they rise in elevation, and between these softer and harder layers we have this, or I should say the softer layer is the yellow layer. And when they carved these blocks out, they made sure to get that layer right in the center of the block. So I guess so they wouldn't have to deal with it, and it looked nice. Member 3, from which the neck and the head are carved, is softer at the neck, which you can tell by the erosion, and harder at the head, which is practically uneroded. This is good building stone, which is why most of it was quarried away, and I'll show you how much of that stone is gone. It'll be blown away. Member 3's durability explains the remarkable preservation of the Sphinx's face while the statue body has been ravaged by the weathering. But there's a lot of factors involved in the weathering of this limestone. One of the reasons that the limestone is so eroded there, because for one thing, it's exposed to the air, it has moisture in it, and a major reduction of the Sphinx, however, is occurring due to salt crystallization aided by the, and they call it the ink bottle pore systems prevailing in these rocks. Well, the smaller the pores in the rock, the more it's going to flake away, because these pores get crystallized and then the crystal expands and it cracks the rock on a very small scale, but it flakes it off enough that the wind can actually blow it off. So that would be the softer layers. The harder layers don't do that. And here's a contour map showing the massive difference in elevation between the Sphinx and the Great Pyramids up here. But you can see that the layering right here is definitely tilted down this way, which means any water in there, or even moisture, atmospheric moisture, even dew eventually, soaks into the rock, but it was still moist from many years ago, and the water slowly weeps and it goes downhill. And we can see here, this was the littoral lagoon that formed. Here's the Sphinx, and this was the member on the bottom, the really hard sandstone. You can see it just barely grazes here. Then we have, this is the member 2 in the middle, very soft alternating layers, and then the hardest layer was on top, and I mean was on top, and went all the way up to here. And of course this is all eroded down from, millions of years. It was probably piled way up here to begin with, millions of years ago. So let's see, we had the inland sea was 94 million, it started receding, so I don't know. I don't know how much could have been deposited and then eroded in 100 million years, but probably quite a lot. And here's a simplified version of that, showing the hard gray limestones on the top and the bottom with the soft marly limestone here. And here's the head of the Sphinx, and it's right in here. Not sure why they're showing that. I think the layer really was probably thicker, but they're probably just trying to keep it to scale here or something. Thicker, and all of this harder limestone layer on the top was actually quarried right off, and then they're quarrying away down here too. And there's also, let's see, where is it? I think it's off to the right over here. They have white limestone. All of the stones in Capri Valley Temple and the Sphinx Temple have been identified and located from where they came around the Sphinx, from the enclosure where they cut everything out. But remember, I said there was an entire layer on top, super hard. That's what the head's made out of. The layers, this layer in the middle is just very soft and erodes. But then notice over here we have these huge blocks are from the topmost hardest layer. So for anybody that's been keeping up on this, there was a big survey and they figured out where all of these stones came from. And everything's coded here. They've got the blocks up here, 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 and then these correspond with the other picture, and then we have some other member F over here. And this photo shows the massive amount of quarrying that was going on right there. And of course all these layers are tilted. You know, honestly, if I was going to build a sphinx, I'm not sure I'd want to. I guess it would be easier since they wanted the soft limestone here to build stuff with. But they still took that whole layer off the top first. It'd be interesting to know where member 3 stones are right now, because those were probably quarried before member 2 stones were, and those are all over the place. As far as the temples go, I don't know how many of these stones member 2 went into pyramids. I don't know how much of the member 3 limestone was used on pyramids either. But there is a white limestone deposit in the area, and I have a feeling they made the casing stones from the white limestone. That's not very far. It's right there up towards the river, up north from where the Sphinx is, I think. I might see it on the geologic map, I'm not sure. It has been repaired a few times. The earliest here is showing 1400 BC, and that would be the, let's see, the, I guess I'm not sure. That for sure the desertification of the area was on. The sand was filling in, and it never rained anywhere from the 18th dynasty on, really. Any moisture that was there before about 2000 BC to 3000 BC, because that was the end of the wet period, where there was this endless rain and so on. So that helps on the chronology as far as dating goes. Okay, so here we are at the actual geologic map of Egypt, and what I'll do is, obviously we can't read this, so I'll have to zoom in a little bit here. Okay, so here we are zoomed in to the Giza Plateau. I'll give you a second here to get your eyes adjusted. But here's Cairo right here. And sorry I don't have my good cursor. This program won't let me use my cool cursor. And the Giza Plateau is right along here, this area. And we can see here that with this whole strip here, which is labeled TE, is the thick marine limestone. And that would be the members 1, 2, and 3. And then if you start going up over here, inward, or inland, we have marine and non-marine screed deposits. Coming inland from there, this whole purplish area here is just conglomerates, clastics, carbonates. But what's interesting here is the TV, which would be the red right here. That is basalt and dolerite dikes. So they had a convenient place for getting dolerite. Any dolerite probably came from here, or basalt. And this was a dike, so obviously they were able to quarry that out. More TPL over here. Now the KU here is just river deposits. And then we have more marine and non-marine pockets here. So it's pretty convoluted here, but on the left here, going westward into the Sahara Desert, we've got TM. Now that goes back to the Miocene, and it's mostly basal clastics. So the thick marine limestone deposit that goes through here, labeled TE, is from the Eocene, and this is about 55 million years old. Now the TPL is Pliocene. It's a little newer at only about 5 million. And then we go back to the TO, which was the clastic conglomerates. That is 33 million years old. And I believe that this is basalt and dolerite dikes go all the way, well, anywhere from the Tertiary to the Mesozoic. So those are pretty old, about 200 million years old. So zoomed out a little bit here, we can see that there's an awful lot of limestone. All of this color here, just TE, is the thick marine limestone. And we follow the Nile down, and all of the yellow is new, recent, quaternary, alluvial, and we keep following the Nile down, and we see that there is limestone everywhere. And keep going, keep going. So they had enough limestone to last forever. But what I'm looking for here now is granite, because you think, well, okay, where did they get granite? Well, they went down to Aswan and got the granite there. And we have to go a long ways to get Aswan. And the reason that they went to Aswan is they could get this younger granite here, which is the GY. And they could just sail it right on down the river. Now they really didn't get it from over here, because there's really no way to, it would just be too hard. Now we have the GO here, which is this one, and you see that all through here. That's old granite, and I'll show you what the difference is in here in a minute. So this is where Aswan is, in the Aswan quarries all over here, and you can see we got lots of granite to pick from here. So let's go look and see what it is. Well, the GY, younger granitoids, Guttarian and all post-tectonic granite, granodiorite, and adamellite. The alkali granite masses of Gabal Ilzit and Gabal Garib are younger. And down here we have older granitoids, syntonic to late tectonic plutonites, essentially of granodioritic composition, previously referred to as gray granite or older granite. So basically they had, looks to me like they only had two choices of granite, but you know, you can see there's a little pockets of gabbro, which is fresh olivine gabbro, norite, troctolite. Here are some descriptions of the rocks we just saw. And you can pause and read that, I guess. This is the TV. There's those little dikes that we see all over the place. Basalt, dolerite. And from different ages. Depends on what kind of tectonic activity was going on, I guess. So all of these little red spots you see are pockets of dolerite or basalt. So if I zoom the map out a little bit, we can easily see why there's so much limestone and other marine deposits in this entire area, because that correlates perfectly with the inland sea 55 million years ago, and all of this limestone of this color is 55 million years. Most of the volcanic activity has been over here, but there's a lot of granite, which means that these mountains were probably a lot higher at one time. So that pretty much does it for the geologic map then. Let's go on to some pictures, and hopefully, now that we look at the real pictures of the Sphinx, when I explain what's going on, it'll all come together. Here we can see the angles of the bedding with the member 2 limestone right here in the middle going through here. We have the member 3 harder on the top, and then the member 1 is down below the layers going right through the middle of the Sphinx here. And that could be up on the top of that pyramid. That I think, isn't that limestone? And if it is, I think it's that white limestone, but I couldn't find anything on the geologic map that showed where they got that. So just for review, member 3 on the top, member 2 in the middle, and member 1, which is the shoal reef limestone, which is the hardest, on the very bottom. So here's a picture of the jointed member 2 limestone, and it has alternating layers of hard and soft limestone, and it has these horizontal hollows going through it where the softer stone was dissolved, and then we have jointing, which causes these lines here. And a lot of people think, well, that must have been just water just pouring off into here. Well, how long would that water have to pour in here, and where would it go? I would think this thing would just fill up. So a lot of this is because of the salt crystallization from the water that was in these layers that comes from higher above. And we can see here there's quite an elevation difference, and water always goes downhill. And here's an old photo showing the Capri Valley Temple here. We have the Sphinx Temple over here, which was supposedly built out of all these stones through here, and it was. This one is the member 3 upper stone, that the same, and I think this is the same stone as what the head of the Sphinx is made out of, but that whole entire layer here has been totally quarried out of here. And this shows your different member layers here. Member 1 here on the bottom being the more resistant, and you can see it looks completely different. Member 2 in the middle, you can't really see any of the member 3 in this photo, probably because it's all been quarried off. And here's the back of the head. This whole top part is the member 3 limestone, and then it gets softer as it goes down and graduates into the member 2, which is easily eroded. So like I showed before, all of these blocks have been accounted for, and when you look, they can tell where they came from, and right through the middles of these stones, I don't know if you can see it very well, but there's this soft layer here called the yellow band, and the yellow bands are between each of the beds, and I think there's only 7 here. And as far as the erosion goes, I'm not saying that water didn't do that, but wind can do that, water can do that, and also the salt crystallization within the limestone can do that, because that's what limestone does. And it happens in layers because this crystallization works in the layers. The harder layers are the more resistant because the water does not dissolve the salts in the stone. Here's another view showing the member 2 limestone here on the left. Down on the bottom here is member 1, member 3, the head, and this entire layer, I mean the whole area was covered with this layer here. That's why it's a plateau in the first place, because this limestone was very resistant, and you get that top layer going across this whole area and you end up with a plateau. Well, they have actually quarried that much material from here, and I think it's just amazing how much rock has actually been taken from the ground and turned into whatever, and probably those pyramids, which leads to the question of who built the pyramids. And the member 2 limestone is badly jointed, and what happens is, jointing means that it gets cracks, and it gets these cracks that are vertical, and a crack is a weakness, and you get sand running down the cracks, and that erodes the cracks and makes them even bigger. So you've got sand grinding down, wind is blowing, doing this, blowing sand all over. The dissolving salts in the limestone form these lateral or horizontal hollows. So it looks like water did all that. But looks can be deceiving. And I know I'm going against a major theory here, but I'll explain that hopefully in a minute too. And here's another really old photo, I think from 1925 or so. And you can see the little yellow bands in the stones here. That's what they use to match them up from the quarry. This whole place is quarry, but the enclosure. This is a Robert Schoch photo where he's trying to persuade people that this had to be caused by water. Well, for one thing, the problem with this picture is we're using two different types of limestone here. The one on the right looks to me like the member 3, which was on top, and it is extremely erosion resistant, but it has soft layers in between. So these soft layers here obviously were affected by the groundwater, and this is where the reaction happened. So we have the picture here showing wind erosion, that this was totally done by wind, but yet no effect here on these faces here. But we have the softer material is gone, but it wasn't necessarily that it was blown out by wind. Then we have the one on the left, and then this picture here showing rain erosion. Well, I'm not saying that rain wouldn't do that, because if there was jointing in this limestone in the first place, it wouldn't have these cracks, and obviously water would hit the joints, and yes, it would run down the joints and make all these cracks. But there's a few problems here with that, because the last time it rained in Egypt was 5,000 years ago. So how long did it take for this to happen? This enclosure was supposedly repaired as early as 1500 BC, but it hasn't rained for 5,000 years. But before 5,000 years, it did rain a lot. It rained for thousands of years before that. So, given that this limestone is going to erode pretty fast under heavy rain conditions, then the question is, when was it built? Well, it was supposedly built during the golden years, and that would be around 2500 BC to maybe 3000 BC. So it was built then, but it hasn't rained since then. It hasn't rained for 500 years before then. So how did this get water erosion on it? The only way that it could happen is if it's older than 5,000 years, which means that's about 1,500 or 2,000 years earlier than what we're told. So if you're going to use the rain theory, then now we have to wonder, well, why would they build something with limestone when it rained a lot? There's also that question, knowing full well that the limestone was going to dissolve. And then rain, back then, there was a lot of rain, right? So it soaked into the ground. So you have the rain between the layers continuing to dissolve salts. But can we go back further than 21,000 years? Because I showed you the map. 21,000 years ago, this area was surrounded by water or still underwater. Because it's not really down the Nile, it's right up at the very top of the bottom of the delta or whatever. So it would have highly likely been underwater. And it probably won't erode like it looks like on the left here if it was completely underwater. So there's that period between 21,000 years and 3,000 years ago when it stopped raining. So could it have been built in that small period of time? Because I think before 21,000 years it was the water was probably even higher, which means they probably couldn't have built all this. And of course the only other possibility is that it was already there from who knows, maybe, and then surfaced, and it was built 35 or maybe 50,000 years ago. So there's all these things, all these unanswered questions we really don't know, but kind of looks like it was built sometime between probably 5,000 and 21,000 years at least. That's my guess. And here's another nice photo showing the member 2 over here on the left, going through the middle, cutting down here into the member 3. I think that is member 3 on the right. And these stones that you see in the distance here, those look like member 3 stone right here. It's a little darker, a little rougher, very hard. This is part of the Aswan quarry, where they had to go for granite, and we can see they used the standard methods here of drilling the holes and pounding in the poles or whatever, and just busting it off in big huge hunks, taking it from there. But on closer inspection, I see the holes, and I can see where they drilled the holes and broke off big hunks of granite here. But what are all these tool marks up here? I mean, what is all that? I guess that could be chisels, but granite's pretty hard to chisel. It's not impossible, but why are there chisel marks here too? Why would you need chisel marks? I mean, why would you need to chisel anything if you're up here just busting off big hunks? Doesn't make any sense. It doesn't look like it was any kind of a particle beam tool or anything. It just, maybe those are just big chisel marks. But why would they be chiseling here? Doesn't make much sense. And they're over here on the right side too. Long ones, big, large, pretty big gouges. Aerial view of the Aswan quarry, and you can see the little tiny obelisk in the middle here. Here's the little one that looks like they were starting a little one here, but there it is right in the middle. And as we saw before, that's where Aswan is. Another view. Yet another view of the member 2 limestone. And also for dating purposes, we might want to consider the rise in sea level about 12,500 years ago, which also receded since then, but not as far down, as it was before the catastrophe, the Great Flood. But looking at the map up here, we can see that the Giza Plateau right here, probably underwater. Hard to tell. Maybe some of it was up here. This is set for only 200 meters, which would be the maximum that I think the sea level could rise, given the amount of ice and stuff. So anyway, something else to take into consideration when we're thinking about the water erosion on the Sphinx, because sea level didn't just rise. There was horrific, probably rainstorm that lasted 500 years. Now that could have taken quite a toll on the Sphinx. So I'm not saying it wasn't water erosion, but it is jointed limestone. And so, if it was all that, so that would mean basically that it was already there, right? 12,500 years ago. So then I think we can just go ahead and say it was there, 15 or 20,000 years and be safe. So, okay, well, I think I've covered all the basics here. So tell me what you think below, and have a good day and stay safe.